Welcome to solverfy.
We're given a weighted graph, and we're asked to use Kruskal's algorithm to find a minimum spanning tree for this graph. The weighted graph comes from exercise 2 in this section. And recall that in exercise 2, we had this weighted graph, and we used Prim's algorithm to find a minimum spanning tree. So we're essentially redoing that problem, but with a different algorithm. So again, with Kruskal's algorithm, first step is to draw the tree, which consists merely of, or is the graph, which consists merely of all the edges, or vertices in the original weighted graph. So the original weighted graph just has the vertices A, B, C, D, and E, and no edges. So we're starting off with this graph here. And in the next step, I want to find the edge with the smallest weight in the weighted graph. So the smallest weight, which is 1 in the graph, occurs between vertices A and B and between C and D. Now first, we'll add A and B. And now if we add C and D, we don't make a circuit, and so this is perfectly valid. So we'll add both of these edges at the same time. Now, in the remaining graph, the smallest weight of 2 occurs between A and E and between D and D. So first let's add A and E. This does not cause a circuit, so that's perfectly valid. And if we were to add D and D, we still wouldn't cause a circuit, so this is also valid. So we'll add D and E. And now notice that we have a connected graph. So the algorithm terminates, and therefore, by Kruskal's algorithm, it follows that the resulting graph is a minimum spanning tree. With edges AB, AE, ED, and DC. So this is our answer.